So for here, problem 34, if cosine of theta equals 5 over 13 and theta is in between 3 pi over 2 and 2 pi, we need to compute sine of theta and cotangent of theta. So cosine is positive in quadrants 1 and 4, because cosine is your x value. And this condition here tells us we are in quadrant 4. Okay, so we can draw a generic right triangle in quadrant 4. And since cosine is 5 over 13, we have 5 in the x direction, our hypotenuse is 13. And if we apply Pythagorean theorem, we get that a is equal to 12. So the magnitude here is 12, but this is in the negative direction. So we have a negative 12 for our y component. So then sine of theta is equal to negative 12 over 13. And cotangent of theta, so cotangent is your cosine over sine. So this is 5 divided by negative 12. Okay. If secant theta is negative radical 13 over 2 and sine of theta is positive, we need to compute tangent of theta. So sine of theta is positive in quadrants 1 and 2. Sine of theta is negative in quadrants 3 and 4. So this part is telling us we need to be in one of these two quadrants. Secant is your x component. Your x is negative in quadrants 2 and 3. And so quadrant 2 is where we need to be. So if secant of theta is negative radical 3 over 2, this is the inverse of cosine. So we're looking at hypotenuse over adjacent. So this would be negative 2, and the hypotenuse is radical 13. Okay. So what is our y value? We can use Pythagorean theorem. We see that a squared plus negative 2 squared equals square root of 13 squared. So we have a squared is equal to, this would be 13 minus 4, which is 9, so that a is equal to 3. This would be a positive 3 because the y is positive in quadrant 2. So tangent of theta is your sine over your cosine. So that tangent of theta is negative 3/2. Number 38, if cosecant of alpha is radical 3 and 2 pi is less than alpha, which is less than 5 pi over 2, we need to compute cosine alpha and sine alpha. All right, so what quadrant are we in? This is going to, so 5 pi over 2, there's 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. You're in quadrant 1. You can also subtract 2 pi from everything. So if we were to subtract 2 pi, we see that we're looking, alpha is in between 0 and pi over 2. So we're in quadrant 1. Draw a generic right triangle, quadrant 1. Cosecant is the inverse of sine. This is the same thing as radical 3 over 1. And so our hypotenuse is radical 3, and our length is 1. So the height Oh, I'm sorry. Cosecant is your sine. So here we have a height of 1. So to find the missing length, we can use the Pythagorean theorem. So this would be 3 minus 1, which is 2. So this would be radical 2. So cosine of alpha is going to be 1 divided by radical 3. Rationalize that denominator, and you have radical 3 over 3. And sine of alpha, oh I apologize for this. Cosine is your x component. Which is radical 2 over radical 3. Rationalize the denominator, and I have radical 6 over 3. Your sine is your y, so this would be 1 divided by radical 3. Rationalize the denominator, and we have that cosine of alpha is radical 6 over 3. Sine of alpha is radical 3 over 3. Okay. Determine the 6 trig functions. So here we're looking at quadrant 3. Let's do a generic triangle here, quadrant 3. Sorry, a generic right triangle. Okay, so if sine is negative 24 over 25, that tells us that our y value is negative 24. The hypotenuse is 25. Pythagorean theorem. It doesn't matter if it's it doesn't matter if it's negative or positive, because when you square it, it's going to turn positive. But let me do this proper. It technically is that. So this implies that a is equal to 625 tells us that a is 7. Negative 7, because we're going into the quadrant 3. So if sine is negative 24 over 25, cosine will be negative 7 over 25. Tangent is sine over cosine. Negative over negative is a positive. And these are the inverses. So this would be negative 25 over 24. This would be negative 25 over 7 and positive 7 over 24. Okay. So here, 270 degrees and 360 degrees. So we're going to be in quadrant 4. Draw a generic right triangle in quadrant 4. And cosine is 1 over 4. So x direction is 1. Hypotenuse is 4. What's the other leg? So we have a squared plus 1 squared equals 4 squared. 16 minus 1 is 15. So this is going to be negative radical 15. The numbers are fine. I just don't like how it's too close to the edge. So that sine is going to be negative root 15 over 4. Tangent is going to be sine over cosine. Cosecant is the inverse, so cosecant is going to be negative 4 root 15 over 15. Secant is going to be 4, and cotangent is going to be negative root 15 over 15, the inverse of tangent. Okay. Here again, we're in quadrant 4. Here we have cosecant is negative root 5. And using this would be a negative 1. So with the Pythagorean theorem, we have a squared plus negative 1 squared equals root 5 squared. This tells us that our x component is 2. Square root of 5 squared is 5. 5 minus 1 is 4. Square root of 4 is 2. So that the sine is going to be two root 5 over 5. Cosine is going to be negative root 5 over 5. Tangent is going to be negative sine over cosine. I did this, jump the gun here. Sine is negative root 5 over 5. It's the y component over the hypotenuse. Cosine is going to be 2 root 5 over 5. Tangent is going to be sine over cosine, with the root 5 over 5's simplifying out. Cosecant is the inverse of sine. Secant is the inverse of cosine. So this is going to be, when you rationalize the denominator, this will be root 5 over 2, because the 5's would cancel each other out. Cotangent is the inverse of tangent. We have negative 2. Prove that the equations hold. So with these, you cannot multiply across the equation, because this is, we're talking about for all values of your angle. And some values of your angle, when you take the secant of that angle, sometimes you get a 0. Tangent of that angle, sometimes you get a 0. With all of the 6 trig functions, cosine of any given angle, sometimes that is 0, is that 0 component. That is why you should not multiply across the equation when you're trying to prove that an equation holds. So for these, we're just going to focus on one side. Sometimes I'll work on one side and then I'll work on the other side, so long as they meet up somewhere. But you cannot multiply across the equation, since sometimes it is a 0. So tangent squared a plus 1 equals secant squared a. I could look up at the top, but what if we just notice that s plus c equals 1? Tangent is sine over cosine. So if I divide by cosine, everything by cosine, what I get is tangent squared theta plus cosine over cosine is 1 equals secant squared theta. So this is the penciled version of what it's explaining this. What if we well, this is one of your basic fundamental identities. Sine squared plus cosine squared equals 1. You divide by cosine, you have your identity here. I realized at the beginning I said you cannot multiply everything by cosine of a value because sometimes it is 0, and yet I have violated it here. Just remember that I remember when I took trigonometry 100 years ago, you could not multiply them on either side of the equation because of that 0 idea. But yet here I did it. And so I don't have a better explanation for that other than please go to tutoring. Thank you.